And now I will show you how to do a cell lineage tracking in 3D. So how to do a parent labeling of 3D cells from an earlier time point to a later time point. So we can open the first time point, going to mesh 1 load. You can go to desktop, root 3 analyzed, open the one already present. Okay, and after that you can open the second mesh, T1. And you can move them apart a bit. Okay, so now we can select parents here, and we need to reset the parents. And so you can fill the parent labels, and you can activate the pick label in mesh 1 and fill parent in mesh 2. This tool will toggle the stack tabs and therefore alternate between mesh 1 and mesh 2 with each Alt plus left click. And if you are already on mesh 1, it will also pick the label of the cells you are clicking on. And so let's press stack 1. So let's say here, left click with Alt pressed, and now it switched tab to stack 2. Once the label is picked and stack 2 is active, move to the mesh 2 and now press Alt and right click. And now you can see that the label is transferred from mesh 1 to mesh 2. And you can continue doing that manually. Double click and then right click. Go to the next layer. You can just use clipping plane, or you can save the parents. And then you can delete the cells that were already parent labeled, so that you have access to the layers below. Otherwise, you can use the semi-automatic method, which is similar for the 2.5 meshes. And to run a single step, you can use the process mesh deformation, mesh 3D, auto parent labeling step 3D, this one. And you can parent label some other cells. Okay. And before running the semi-automatic lineage tracking, you need to run the mesh heatmap analysis, cell analysis 3D. Okay, and now you can run deformation, mesh 3D, auto parent labeling step 3D. And now some of the cells were parent labeled, and so you can double check if the parent labeling worked. You can modify the cells. You can correct some of the cells. Now you see some cells were parent labeled, and you can check if they are correct. And you can save them, save the parents. And then of course you can finish with the rest. And to not take too much time, we can load the parents that were already parent labeled. Okay. And now I can show you how to generate the principal directions of growth in 3D. So first of all, we have to create a deformation function like we did for the 2D samples. And we can do it in deformation, mesh 3D, create deformation cell volumes with stack 1 active. After that, we can hide stack 2 and keep only stack 1. And we can create the growth directions of your choice. And to do that, you need to run the process mesh cell axis 3D deformation gradient compute. And you can select here the mode. So you can have for whole 3D cells, you can select either cell or stack. So a growth tensor is assigned to each cell, and the tensor is determined from the deformation function either at the cell centroid or averaged across the inside boxes of a cell in stack. And this stack requires a loaded segmented stack with the same labels as the cells. And then you can select vertex. So this mode is similar to the subcellular PTGs for surface meshes, and for each vertex the growth tensor is shown projected onto the surface of the mesh. And then we have cell wall. So for individual cell walls, same as the vertex modes, but the tensor of the cell wall are averaged, and this mode requires the computation of the attribute map of individual cell walls. So the process mesh cell mesh tools label cell walls with only attribute map yes. So we can run, for example, this one. This heat map shows how much the cell wall elongated, and so you see the principal directions of growth that is vertical, that corresponds to the axis of the growing root. And you can also cut through the root, and you can see inside.